and things and so. Then coming to the final part of my presentation, the compartmentation and how we are achieving this. Now the main thing about passive fire protection is compartmentation, containing the fire within a particular compartment without allowing it to go to the next one, internally or externally. So it should not spread internally to the other compartment, externally it should not go to the next building, or externally it should not go to the next level through the openings. So let's watch it for 2 minutes and then I will continue. So why compartmentation is needed? Until people evacuate and until the fire brigade that controls the fire. So how we can achieve is through by fire barriers, fire rated doors, if you have openings or fire rated compartments. So the door should prevent the fire from going to the other side, and penetration should be sealed so that through the penetration the fire will not go to the other side. So it can be the serving fire stops or service fire sealants or fire stops, and right compartmentation is essential in saving lives. So these 2 small videos show you what happens when the compartmentation is lost. The first one shows you a sort of a fire that is happening in a fireworks shop, not in Sri Lanka, luckily in I think India or Bangladesh. So fire is not contained within that particular compartment, and within couple of minutes you may see what happens. So if it is somehow contained within that particular compartment, only that particular shop may be damaged, but now with the compartmentation is lost, it spreads to the whole neighborhood, increasing the risk. Right, so you can imagine what will happen next. And the next shop catches fire, the next one catches fire, so it goes on like that. Again, loss of compartmentation in a high-rise building, mainly due to combustible facade. Right? So here also now the compartmentation is lost because the fire has gone to the balcony and it is now spreading to the next compartment. Now this cladding catches fire, and because of that cladding fire, it sort of accelerates. And within minutes, it is spreading horizontally and vertically as well. Right, so you can imagine what happens. So mainly deals with containing the fire. So in terms of penetrations, we should have fire collars, dampers or fire sealant to protect this penetration. In terms of doors and windows openings, these should be fire resistors. So this fire resistant level, I mean, unlike active fire protection systems, once they are installed, we cannot check them. Because if we check them, I mean, that is again destroying or disturbing that particular system. So what we have to do is test them before you install. So that is where the standard testing comes in. So this shows you an example of a standard fire test for a penetration system. So what we have is a furnace like this. So inside this furnace we can generate the fire curve that I have shown you, the sine fire curve or any fire curve. And in that particular fire curve we look at for how long this system can contain the spread of smoke or the flames to the other side. In terms of these penetrations, the smoke is allowed to a certain duration because we can't prevent 100% smoke to a certain duration, at least until the system or the sealant get activated, smoke will come out, but then after that the smoke will will seal and smoke will stop, but the flame spread should be prevented.